Hello, my name is Brendan.
And I'm Chris. This video is a demonstration of our implementation of real-time gesture recognition using OpenCV.
Through the application of segmentation, open hand detection, and curvature analysis, we were able to recognize predefined gestures using a finite state machine. In our implementation, a recognized gesture is a word made up of different characters. Our alphabet consists of 3 characters which are used to spell different words. A circle is represented by 1, a piece is represented by 2, and a 5-star is represented by 3. Additionally, there is a ground state where a hand is still detected but no character is recognized.
The ordering of these characters can be used to represent 4 words. We deliberately did not create words for all possible combinations in order to demonstrate error handling within our finite state machine. The 4 words are as seen on the screen. Gesture 1, for example, is recognized by performing a circle, followed by a peace sign, followed by a 5-star. To demonstrate that the word was understood, a specific action is performed. In this case, terminal is opened.
Similarly, other gestures have been defined and can be seen on the screen.
Due to the quick nature of the real-time video demo, we will give a brief introduction to the way the program initializes and resets a gesture.
At the beginning of the program, or whenever the program loses track of the hand region, the user is prompted to initialize a hand region. We do this using outstretched hand detection. Because of the similarity between outstretched hand detection and the 5-star character, the gesture cue may need to be reset by using the ground state in order to start a gesture that does not begin with the 5-star character. This is only required immediately after initialization. Additionally, ground state can be used at any time to reset the gesture in case of user error. This is done by holding ground state for a predefined number of frames.
You will notice that when the peace sign and the 5-star characters are presented to the camera, the program quickly locates the fingertips, valleys, and palm. Similarly, you will notice that the camera feed shows a binary image when the program detects the circle character. This is done to assist with visualization.
With this background knowledge, we will now show you a demonstration of the program in action. Alright, so let's open up the program. I start it and tell it to use the camera as the input and to open up programs when it recognizes gestures. There I've initialized it and I'm performing a couple alphabet characters, and that recognized my first gesture and opened up calculator. I performed a different gesture, so it opened up opera. You'll notice when my hand leaves the screen it asks me to reinitialize. So I reinitialize and I begin a new gesture. I'm sitting at ground state right here so that I can start a different gesture that doesn't start with a 5-star. There I opened up terminal by performing a third gesture. Reinitialize. Get the gesture to reset. And here's my final gesture. And that opens up Firefox. Now I'm going to try a couple of alphabet characters that are never at the beginning of a word. 2 is never at the beginning of a word, so by performing it, I get an error. Reset the gesture by ground state. 5 is never followed by a circle, so that gives me an error as well. Alright, there we have it. This concludes our presentation. Thank you for watching our demonstration. We highly recommend the University of Victoria's Computer Engineering 421 course to anyone with an interest in computer vision or video processing. We would also like to thank Dr. Albu, our professor, for her support, guidance, and patience.